Tonight's lecture is entitled, Madame Curie, the Mother of Radioactivity. What you have just seen, you all recognize as being the first atomic bomb. Exploded July 16, 1945, Alamogordo, New Mexico. Now, I'm not suggesting to you that Madame Curie made the atomic bomb. She, of course, did not. Madame Curie had no idea that her discoveries about radioactivity might someday be used to develop an atomic bomb. Her goal was to use radioactivity to make advances in medicine and science, all of which came to pass. And had Madame Curie lived long enough to see the advent of nuclear weapons, she would have been sadly disappointed. Now, why do we call it the atomic bomb? An atom bomb. Does that mean that an atom is exploding? Well, you know, in one sense, that is true. There are many different kinds of uranium atoms. You had the most common everyday uranium atom, which is the atom that Becquerel used when he was exposing his film with the uranium salts. But if you look at an individual uranium atom, and it decides, I'm not trying to tell you it's thinking about it because we have no idea when an atom will disintegrate, a word that Rutherford used. But when it does, it is a mini explosion. The everyday uranium will explode once, let go of an alpha, a beta, and a gamma ray, and that's the end of it. In the work of the atomic bomb, you had a particular kind of uranium. And this uranium would release a particle, a neutron, which could now stimulate other uranium atoms of the same breed to release more energy and more energy and more energy, and you get a chain reaction, and finally you have the atomic bomb. Today, every school child knows that atoms are consisted of subatomic particles. But this, of course, is quite a recent concept resting on the shoulders of people like Madame Curie, her husband Pierre, and Rutherford. Up to that time, scientists and philosophers from almost the beginning of time, from a man called Democritus, which is 5th century BC, predicted that there were atoms, and these atoms would never change. Now you might ask me, how did Democritus in the 5th century BC predict atoms? And I'll give you a good example. Let us say I have a sheet of paper, it's my tool, and I take it and I cut the paper in two, I tear the paper in two, I get 2 pieces. And now again 4 pieces, and again 8 pieces, 16 pieces, 32, 64. How many times can I divide this piece of paper and every piece that I get is still paper? And 500 BC, there were 2 schools of thought. One school said, oh, you could do it forever, ever and ever and ever, there'll always be paper. And Democritus said, no. I think that when you get small enough, you will get an individual particle that is not divisible anymore. And we call that particle an atom. A without atom cutting. And this concept that atoms are the most basic and the end of the line in terms of material. Everything can be constructed by atoms, and you can't go any further. That was a wonderful insight of Democritus. Now, Madame Curie, although she was basically a physicist and a mathematician, was very familiar with chemistry. And certainly she was familiar with chemical explosions. And even the early chemists could take an equation like gasoline. You put gasoline in your car, it combines with oxygen, you have an explosion, and on the right side of the equation, you have water, heat, and a lot of other stuff. That's a chemical explosion. The energy comes from the chemical bonds. Probably the most well-known explosion right now is what drives the space shuttle. These big, big tanks. You have one huge tank filled with liquid hydrogen and another with liquid oxygen. And you just mix them. Well, you don't mix them right away, you mix them very judiciously. But the energy of oxygen, O2, plus H2, going to water and a huge explosion is what drives the space shuttle up. It's a typical example of a chemical explosion. Now, chemical explosions like a forest fire, your burning house, these are all chemical. But in the universe, most explosions are not chemical. They are atomic, better word would be nuclear. In fact, the origin of the universe was actually what was called the Big Bang theory of the universe, first proposed by my father and his students back in 1948, and known as the Big Bang theory of the universe. Now, I started my lecture with an atomic bomb, mentioning that Madame Curie laid the first brick that had led to the atomic bomb. So I now want to go back and talk about her exclusively because she is probably one of the most unique scientists, woman or man, that we've ever had. It was tough. When she was only 10 or 11, her mother died. And that had a tremendous effect on her. But she was still going to school under terrible circumstances and graduated highest in her class when she was 15 years old. She made a deal with her sister that she would work for a number of years and send the money to her sister, for the sister could become a doctor. And then when the sister was earning money, she would send money to Maria. And she would be able to study. In 1891, she had enough money, just enough money, to go to Paris and pay the tuition at the wonderful, beautiful Sorbonne University in Paris. She reminded me of the opera La Bohème, living in very, very tough circumstances in a cold water flat. It was so cold that she had to sleep with her clothes on. After she finished her degree at the Sorbonne, she began working at an industrial school doing experiments on magnetic properties of various steels. It was there she met a teacher at the school, Pierre Curie. She fell in love with Pierre, and they married in 1895. She was now Madame Curie. 2 years later, they had their first child, Irene.